Okay, so today's worksheet. Let me get scrolled to today's. So on this one, like I said, most of the questions today, you're looking at finding an angle. I don't really like how I worded this first one, but like I said, this one is pretty much the same as number, that's number 5. We need 7 freeze. That's the problem. So number 1, it says from the top of a vertical cliff 40 meters high, there's an object that's 155 meters down the cliff. What angle of depression is the object down? So I've got a 40 meter high cliff. So that's 40 meters. Now, from what I was saying, like I said, I didn't word this real well. There's somebody kind of standing up here looking down at an object down in the cliff. From where they're standing to the object is 155 meters. Now remember, angle of depression, they're always a little bit tricky because they're not really even part of the triangle. So the angle of depression is going to be here. Angle of depression. But then this is the angle I'm going to actually find in the first place. So once I find the angle inside the triangle, I'm going to find the angle of depression. So it takes the extra step. So here's my 90. So I have a hypotenuse, I have an adjacent, which means I need to use cosine. So cosine of this angle here equals AH, 40 over 155. Now, does anybody remember what do I have to type into the calculator if I'm finding an angle?
Cosine.
It is cosine, but remember, if I'm finding the angle, you have to do the inverse. You have to do the inverse one. I'm not going to write this on the rest of them, but I just want to make sure you remember that. You got to do the inverse cosine of whatever the fraction is. So make sure you do the inverse. So second cosine, or if you're using Desmos, just type the button. You get 40 divided by 155, and I get 75 degrees. So the angle inside the triangle is 75 degrees. So that's this guy. But that's not my angle of depression. My angle of depression is the one outside. So this is 75. How big is my angle of depression that's outside the triangle? Remember, this whole corner is how big?
15.
It'll be 15. Because the corner is 90, if you subtract the 75 we just got, the angle of depression is 15. And so remember, the angle of depression always takes an extra step. If I give you the angle of depression, you'll subtract from 90 to get the angle. If I'm finding the angle of depression, take 90, subtract the angle we get to get the angle of depression. Number 1, are we okay?
Yeah.
So let's look at number 2. An airplane takes off 200 yards in front of a 60-foot building. At what angle of elevation must the plane take off in order to avoid crashing into the building? Assume the airplane flies in a straight line and the angle of elevation remains constant until the airplane flies over the building. Now, the first thing that we notice, they say that it's 200 yards in front of the building, and the building is 60 foot or 60 feet. Well, we have a problem there. What's the problem?
Yards and feet.
Yards and feet. And I don't want to have yards and feet, so I have to change them both to the same thing. So you have a choice. You can either divide this by 3 to make it yards, or you can multiply this by 3 to make it feet. I'm going to divide this by 3 just to make it smaller numbers, so we end up with 20 yards. And this particular problem I actually found online, and there was a key to it, and they actually did it wrong. You can't always trust everything you find online because sometimes things can be done wrong. This particular one, whoever made the key did it wrong. They forgot to change the units. So I have a 200 yards in front of a building, and then my building is 60 foot tall, or 20 yards tall. So the building's 20, and it's 200 yards in front. There's my triangle. I want to figure out the angle of elevation. So that's this guy. Opposite adjacent. So that's going to be a tangent. So tangent, I don't know the angle. Opposite, adjacent. There's my set. Now, like I said, you need to find the angle. To find the angle, you're going to hit the inverse tangent, 20 divided by 200, and I get 5.7 degrees. So the angle that the plane has to take off is 5.7 degrees. So that's this guy here. So that's number 2. Question number 2. Number 3. You all good? A 14-foot ladder is used to scale a 13-foot wall. At what angle of elevation must the ladder be situated in order to reach the top of the wall? So my ladder is leaning against a wall. So here's the ladder, here's the wall. So the ladder is 14 foot, and the wall is 13 foot. And I want to figure out what angle this is going to be length. So that's X. Well, I knew the hypotenuse this time. Because if this is my 90, this is hypotenuse, that's opposite. So I have an opposite hypotenuse. So that's a sine. I don't know the degree. 13 over 14. That's my setup. So inverse sine, 13 over 14, I get 68 degrees. So the angle of elevation, the angle that the ladder is laying, is 68 degrees. 68. So that was number 3. Number 4 is just like number 4 yesterday. I give you the angles. It's pretty much the same thing as number 4. I'll go ahead and do it, which means 9 on the back is just like that also. Oh, I think we're written. So same as yesterday, I'm going to end up having to find kind of 2 answers. And then it wants to know how far apart the ships are. So then I subtract. So my clip is 380 this time. I'm going to make my triangle. My clip is 380. First, it says I have a 9-degree depression. So that's 9 here. So that means I've got to subtract from 90. So it means I'm actually using 81. And then this is what I'm looking for. So I'm looking for how far out the ship is on the sea. So that's the X. So there's my picture. Well, it looks like I have an O and an A. So tan of 81 equals OA, X over 380. That's my set. Same as yesterday. To get rid of a divide by 380, I'm going to multiply by 380. 380 times tan 81, I get 2,399 meters. Now the second one's going to be pretty much the same thing. The only difference is instead of a 9, it has a 5 degree. So inside is now 85. My setup's going to be the same. Still tan. This time it's 85 equals x over 380. To get rid of it, divide by 380, multiply by 380. And that equals x. So I'm just going to change the 81 to 85. Change that to a 5, hit enter. 4343, 4,343. 4,343. Now we're not quite done because the question wants to know how far apart the ships are. So the one ship is 2,399 out. The other one's even farther at 4,343 out. So if I subtract my two numbers, subtract 2,399, 4343, subtract 2,399, I'm 1,944 meters apart. So that's how far apart the ships are on the water. That's how far apart the ships are. Are we okay there? And number 5. So number 5. A ramp is needed to allow vehicles to climb a 2-foot wall. So I have a wall. I have a ramp. It's a 2-foot wall it's trying to climb. Now it does give me a degree. It says that the ramp needs to be 30 degrees or less. But I don't want to use that yet because it tells me how big the ramp actually is. The ramp is 5. So I want to figure out what angle the ramp is actually at and then see if it's safe because it needs to be 30 degrees or less. So I'm using how high the wall is, how long the ramp is. It's an OH, so sine of the angle OH, 2 over 5. Again, don't forget to do the inverse sine, 2 divided by 5. And I get 23.6 degrees. So this ramp is sitting at 23.6 degrees. Well, it says to be safe, it has to be 30 or less. So was it 30 or less? Yeah, 23 is less than 30. So therefore, it's not too steep. Because it had to be less than 30 for the truck to make it safely. So my final answer is yes, it is safe. So the 30 was just used as a comparison. So I had to figure out what degree the ramp was sitting and then say, okay, was it safe or was it not safe based on the 30? Questions on the first 5. You have the remainder of the class period to work on the fact 5. Tomorrow, I'll do the same thing as I did today. I'll look to see who has it done. We'll talk about it, we'll go over it, and then that's going to finish up our triangles. Tomorrow, then we start circles. So tomorrow we start circles. So that's the plan. Don't forget we have 3 weeks till the end of the quarter. This week, next week, the week after. So be looking at your grades. Be looking to see what you need to possibly make up. To see if you can get your grades up if they need to be up. Some people are doing pretty good. Some people are really struggling this quarter. So definitely look at your grades. And if you see any problems with your grades, let me know.